Hello there, welcome back to Trigonometry. I want to introduce you to some very special triangles and their special angles today. The, uh, these angles are going to be coming up a lot in the rest of your trigonometry course of study. So we need to introduce them now and you can start getting really familiar with them. So we're going to look at some special triangles and their angles. Well, let's thicken that a little bit. Let's make that like a width of 3, be easier to see. Okay, so special triangles and their angles. And with this, we're going to be looking at their various trig ratios too. Okay, first let's look at a triangle that's equilateral, equiangular. In other words, when you draw the triangle, all three sides are the same length and all three angles are the same measure. Now I'm just quickly sketching a triangle up here. Don't measure it. All three sides are not literally the same, but let's just say they are. And let's just say that the sides have some kind of length of 2 units, so it's equilateral. And then the angles are, since there's 180 degrees in a triangle, if all three angles are the same measure, then each angle must be 60 degrees. Equilateral, equiangular. All right. Now let's take the same triangle and let's split it in half. Let's start up here at this vertex and go straight down so that we make a nice little perpendicular here. Let's split it in half and then let's look in greater depth at a half of this. Okay, so if we just look at half, we've got a right angle right here. Then this side here is still 2 because that corresponds with this side. And then since we split it in half down here, if this side was 2, then each side here is going to be 1 and 1. So we got a 1. Then I'm trying to figure out what the length of this side is. We can use the Pythagorean theorem to help us out. Because we got a squared plus 1 squared would equal 2 squared. So it is a right triangle. So a squared plus 1 equals 4. A squared equals 3. So a is plus or minus the square root of 3. But we're dealing with the length here, so we'll go with plus. So we got positive square root of 3 for the length of that perpendicular we had drawn before. All right, and then the angle measures. We know this one's 90. This one is 60 degrees still, because that's still this angle here. And since we cut in half, this 60 degrees up here got cut in half, so we have a 30 degree up here. All right, so this is a special triangle, 30, 60, 90. And you're going to see it quite a bit. And I want to go through and analyze what the sine, cosine, tangent, etc. would be for the 30 degrees and for the 60 degrees. And you're going to want to be familiar with these values from here on out. So if you know how to derive them real quickly if you forget, but if you memorize them, that's good too. All right, let's go with the 30 degrees first. Sine of 30 degrees opposite over hypotenuse is going to give you 1 over 2. Cosine of 30 degrees adjacent over hypotenuse is going to give you square root of 3 over 2. Tangent of 30 degrees opposite over adjacent is going to give you 1 over the square root of 3. And once you rationalize the denominator, you'll end up with square root of 3 over 3. Cosecant of 30 degrees, you're doing the reciprocal of the sine of 30 degrees, so you're going to get 2 over 1 or 2. Secant of 30 degrees, you're doing 1 over the cosine of 30 degrees, so you get 2 over the square root of 3, but once you rationalize the denominator, you get 2 square roots of 3 over 3. And then cotangent of 30 degrees, You're doing 1 over the tangent, so you get square root of 3 over 1 or square root of 3. Okay, so we have those values there. Now let's do the 60 degrees. We're going to be doing sine of 60, cosine of 60, tangent of 60. We're going to be doing cosecant of 60, secant of 60, and cotangent of 60. Now really you don't have to do a whole lot of work because you're dealing with cofunctions again. We just learned about cofunction identities. We learned that the sine of 30 degrees is the same thing as the cosine of its complement, which would be 60 degrees. So if the sine of 30 degrees is 1/2, the cosine of the complement, 60 degrees, is also going to be 1/2. That was from those cofunction identities. We learned that the cosine of 30 degrees, if its cofunction, will have sine of 60 degrees. So we do square root of 3 over 2 for sine of 60 degrees. We know that the tangent of 30 degrees is going to work out to be the same thing as the cotangent of 60 degrees. So square root of 3 over 3. We know cosecant of 30 is going to work out to be the same thing as the secant of 60. So 2. The secant of 30 is going to turn out to be the same as the cosecant of 60. So 2 square roots of 3 over 3. And the cotangent of 30 is the same as the tangent of 60. So square root of 3. Or you could go back and look at your right triangle. And that'll verify it too. 60 degrees, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Cosecant, reciprocal of sine. So 2 over square root of 3, or 2 square roots of 3 over 3. Secant, reciprocal of cosine. So 2. Cotangent, reciprocal of tangent. So 1 over square root of 3, or square root of 3 over 3. Those are some special angles there. So you do want to be familiar with these. If you can get to the point of memorizing them, that's awesome, because you're gonna see them a lot. For 30 degrees and 60 degrees. Okay, another special case, 45, 45, 90. Let me draw that triangle for you. Again, I'm just sketching. This is not perfect, so don't go measuring, because my sides are not going to be exact, but at least this will paint you the picture, give you an idea. I'll be consistent. I used red and blue. Okay, so we have right triangle here. Let's say we have one where we're dealing with these two angles are congruent. They're both going to be 45 degrees. So remember, the two acute angles in a right triangle have to add up to 90. And in this case, if these two angles are the same, then these two sides have to be the same. It has to be an isosceles triangle. So we have an isosceles right triangle here. And let's go ahead and let those sides be 1 unit each. Now to find the hypotenuse, we got 1 squared plus 1 squared equals c squared. So 1 plus 1 equals c squared. 2 equals c squared. Use the Pythagorean theorem. C is going to be the square root of 2. Because once again, we're dealing with lengths, so we'll do positive square root. Knowing those values, we can go and deal with 45 degrees and find sine, cosine, tangent, cosecant, secant, cotangent. And that's another special situation. So sine of 45 degrees, opposite over hypotenuse, would be 1 over square root of 2. And once you rationalize the denominator, you get square root of 2 over 2. Cosine of 45 degrees, adjacent over hypotenuse, 1 over square root of 2 again. So again, square root of 2 over 2. Tangent of 45 degrees, 1 over 1, so that's going to be 1. Then when we get to cosecant, 45 degrees, we're doing the reciprocal of sine, so square root of 2 over 1, or square root of 2. Secant of 45 degrees, That's the reciprocal of cosine, so square root of 2 over 1, or square root of 2. And then cotangent of 45 degrees, it's the reciprocal of tangent. 1 over 1 is going to be 1. So there's some very special angles, some very special values. You're going to want to make sure that you're familiar with all of those, or can at least quickly derive them using the right triangles and so forth. So know all of those. Be very familiar with all of those. Okay. Well, that's all the special angles that we're going to have to worry about. So you got your 30, your 60, and your 45, and then and we'll start using these in the future. We're going to use them for looking at something called a unit circle and doing some other stuff. So, all right, hope you'll join us again next time. We're going to be heading into looking more at reference angles and applications and so forth, and then eventually the unit circle, which will be a lot of fun.